Now, so a non-linear relationship is transformed to a linear form. So you may want to highlight this. So let me start the story again. So what are we trying to achieve here? Kunj? We are trying to sketch a graph. Kunj? We are trying to sketch a graph with y equals to x. Now, all experimental value, if you go and conduct experiment in science, in geography, history also can, you realize that this probably will be a real curve. Uh, because of the data that you collect, right? But then after that, what you can do is you can transform it into a straight line. Now, once you transfer into a straight line, you will see something like that. Across, 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 across. So once you see a cross like that, what it means is that Kunj, this is a experimental error. So this is the purpose of linear law. The purpose of why you want to do linear law is this. Say for example, I want to do an experiment. I want to time the speed of a toy car. So what do? I take the toy car, I put on the floor, and then I time. Then I time when it stop, then I call it a time. Now, hey, you want to continue the lesson or not? Now, so in this kind of experiment, right? Let's say I collect 10 data. I collect one timing, two timing, three timing, four timing. I collect 10 timing already. How do I know which timing is wrong? So I collect the timing already. I transform it into a linear graph. Then I realize all the timing actually fall on a straight line, except for one strange timing that is way out. Then you know this is a wrong timing. Wrong timing is there's an error. Maybe that time you are talking to the Dexter, and then that's why you forgot to press stop, something like that. You understand the idea here? So linear law here, the main idea here is not to torture you. The main idea of linear law is to confirm, to identify any inconsistent data. Because when you perform an experiment, definitely you will follow a pattern. But because of human error, because of people refusing to shut up, somehow you will forget to stop the stopwatch or things like that, and then it will create error. Okay, so this is the real purpose of linear law. Predict data means this. For example, if I can predict this data like that, right? Then I will say, oh, if x is okay. So for example, x is a distance. Example, x is a distance. So I capture the distance from 1 meter to 10 meters. From here, I can predict 100 kilometer here. Where is the speed? Something like that. You can predict the data later. Do you follow? Can So these are the two purposes. But in order to do that, we have to first learn how to draw a simple linear graph equation. Can we start? Can Sure. It's okay. By the time I finish the story, next lesson you bring graph paper. Where's the pass? Oh. Okay, so let's take a look here. So this table here, so this one is a fake experiment. So this table here, it will follow this weird equation. Can you make a guess? This weird equation look like a straight line or curve? Confirm curve. Square root x on top and denominator some more, plus and minus some more. Confirm is a curve. So what happened here is I want you to plot this against this. So can you write down this is your y-axis? This is your x-axis. The first one is always vertical. Kunj. So then I want to estimate the value of A and B. I want to estimate the value of A and B. So now I try. So I look at this. This is the first one. You have to, first step is to arrange it into the big Y equals to M big X plus C. Is this the same first step that we mentioned earlier? Yes, right? So we look at the equation here. Y. But I look at the big Y I compare. What is the difference? Here got square root x, here don't have square root x. So what do you do throughout? So Charlene will times square root x throughout. Do you follow? So you get hint from the vertical axis. So I highlight for you to follow. So if you were to highlight two things, if you were to highlight y square root x and y, you know that you have to multiply square root x throughout the equation. What? No. Okay, multiply. Like times. Okay? Yeah. So somewhat like that. So what happened is over here you can write y times square root x. Then you maybe you can write a note here. What is square root x times square root x? X, huh? So this one, Junyang, we learned in the indices already. So this one will be ax plus. So if here times square root x on top, square root x below, you will cancel away. So only left with this. So this is the next step. Bad. Okay. Now, what I'm going to do is I'm going to multiply square root x 3 times. Do you follow? Do you follow this step to and this step? I multiply square root x. This one, I also multiply square root x. This one, I also multiply square root x. So the first one, y square root x remains here. The second one, root x times root x will give you x. Then root x on top, root x below, they cancel off each other, only left b. Can follow? Okay, so I look at this now. What this is already my big Y and big X. So what is my gradient? A is the gradient. So this is very important. So you write down A is the gradient. A equals to gradient. And then B equals to y-intercept. Okay? All these three steps are very critical. So I don't draw star already. Now, step 3 is also very critical because without step 3, you can't draw a graph. So, Kunj, look at the original graph. You have x and y. The original graph, you have x and y value. But you have a problem here because x and y here don't coincide with the big y axis. Do you follow? Because the big y axis is what? Y square root x. So what happens is you need to create another row of table which says y square root x. So this is created. Do you follow? So over here, you need to create the y square root x row. So now, since this is a new row, it is created, I need to fill in the blanks. So I look at the first one. First one say x is 1. So if x is 1, y is 1.1, right? Then I ask myself, what is y times square root x? So I'll take y is 1.1 here times square root 1, which is here. Do you follow? So if I can color it, right, I will color this box linked to this box. So if I take out my highlighter, I will probably highlight this box with this box. Somewhat like that. So it's linked, it's linked. So I use the top 2 value to find the bottom 2 value. Okay? So over here, the answer will be what? 1.1. Yeah, keep it to 1 decimal place. Round up, round up. Yeah, please keep it to 1 decimal place because later on the graph paper, you are unable to draw to 2 decimal places. Now, look at 3 here. Who is confused? I do with you. Anyone confused about what I'm saying? All clear. So if all clear, I will link this to this value. So do you know how I get 4.9 times square root 3? All clear. Okay, good. Then what is the answer? 8.5. Last one. 15.9. So once I have this, yay, done. I can draw my graph. Clear? Clear? Huh? Good. Story. Now, so now let's continue the story. Now, draw a suitable straight line. This is what happened. Tomorrow is Thursday. We only have one period, right? Right. So, bring your graph paper. Can I request all of you to prepare the crosses? Don't join the line, then we talk together. So, I will give you one question later as homework. Prepare the table, prepare the cross, but don't join the line. Now, but let me explain what is best straight line. Can you highlight this word? Draw a Mingyuan. Can you ask the class to underline this? Draw a suitable straight line graph. Now, I'm going to give you example on what is a suitable straight line graph. So, what I will need you to do over here is to draw out some of the example of a suitable straight line. Xing Hui. So, can you write down example? Come on, come on. Few more minutes only. Suitable straight line. So, the suitable straight line example number one, Jingfeng, is like that. Now, later on when you draw the graph, you will realize, hey, there is no way I can put a straight ruler that will join these 4 points together. If I join it will be like that. Okay? So a suitable straight line means the total distance on top must be equal to the total distance below the graph. Again, so you must adjust your ruler. You must now if you get this wrong, later on all your gradient wrong, all your y-intercept wrong, then all the below part all wrong. So let's recap. Let's say it again. Now, if you were to join these 4 points, you realize it's not possible to have one straight line because the line will look like that. Go up, slant, then go here. Then it is wrong. So suitable straight line means you will draw a line that join most of the points. And those who don't join, you measure the on top distance will be equal to the below distance. Must be the same. If you're saying that this is the best straight line. Huh? Yeah. So let me give you another example. This is also a best straight line. This is also best straight line. So for example, I have something like that. 1, 2, 3, 4, then got 5. Then you realize, then the question will ask you, hey, can you identify which point is the error? Then you will say, oh, this is the error. Because this is too far out. There's no way I can draw a back. If I make my line, go and join this point, then you realize that all the others will be way below. So very obvious this is the error. So 2 marks is given for you to identify the error point. You must be able to identify. Far away means this is far away. If this is 1 mm, this is 1 mm, this is at least 3 cm. Far away, very far away from the rest of the point. 2 mm, 1 mm, then it's not. If this is 2 mm, then this is not an error. 2 mm means it's somewhere here. Slightly longer, but still close to the line. What's your question? Huh? E-math have. E-math have or not? You must look at the assessment info again. Later when you run through revision, then you will see. Now, tomorrow, can you bring your graph paper? Shh. Don't keep your things first. Look at the question here. I need to do practice 4. Alright, so tomorrow, when you come to class, you must be prepared with... Shh. Hey, don't keep first, You must be ready. So 1st of August, you must have your graph paper. You must have the axis drawn and all the crosses drawn. But don't need to join. We come together, I will adjust the ruler, we discuss which one is the best straight line. You don't come with this prepared, you are going to waste that one day. You don't learn anything because to them, to those who have done, the graph means a lot. Draw the crosses. You want to join, can join. If you're not trying to join, at least come with this prepared for this question. All clear? Tomorrow. Thank you, class.